Everyone, and in today's video we're going to look at some additional vocabulary terms in this first unit of geometry. In particular, we're going to look at terms numbers 15 through 24, which are the last terms in our first unit section here. So we're going to get started with coordinate, and just so you know, at any point in this video, please feel free to press pause to kind of catch up if you want to listen to what I have to say first, and then from there you can press play for more stuff. So I'm going to go through this fairly quickly, though. So we're going to start with the term coordinate, which you've probably heard about from number 1 and PropStat. It's a location in space represented by x, y. I'm going to go over here to the drawing side and draw a quick coordinate plane. And if I have a point right here, okay, we typically can locate that point and identify that point by its x coordinate and y coordinate. That is, how far to the left and right you go to locate it from the origin and how far up and down you go. That's x and y represent. As an example, this is the point 2, 3. That means that we would go over 2 units from the origin, and we would go 3 units up on the y-axis to create where the point is. So just as a reminder, the 2 is an indication of your x-coordinate. That's how much an object moves left or right. Is the y value, which is the vertical movement up or down. Moving in that same category here, we're going to talk about distance, which can also be at the same time concurrently called length. Okay, that's the amount of space between 2 objects. Okay, and when you see that, or when you see that distance, sometimes you're going to see the notion here. What is the length of AB, for example? Well, AB, notice that there is no segment symbol listed above there. When there's no segment symbol above there, they're not talking about the actual shape. They're talking about its length. Okay. So whenever there's not a line symbol above that or array symbol or anything like that, we're looking at an actual length. And in a future lesson, we're going to learn actually how to find the length between 2 points. The way that we're going to do that is called the distance formula. So I'm going to have you write that down now, but just know that we're not going to be discussing anything about this further until we get to some point next week. All right. Now, staying in that same area here, sometimes we are going to have points that are between 2 other points. And so we use the term between for that. That means a point that is inside of 2 other points. So an example here is we could say that point B is between A and C. Now, some textbooks and other worksheets you might see might use this notation where they go A dash B dash C. And what they're indicating is that this is in between. Now, between is really, really important. It's different than middle. It doesn't mean that B has to be directly in between A and C. Let me try that second one. Sloppy. So we have a segment here that we're going to call AC. The B can be anywhere we want when we say between. It doesn't have to be in the middle. So for the example in your notes here, I'm just going to put a B right here to show that that is one particular place where point B is actually going to be between both A and C. Now, what if B happened to be directly in the middle of A and C? So I'm going to draw another segment down here, okay? And it's also going to be called AC. And I'm going to put B directly in the middle. What that's going to mean for us, and let me change over to a red pen here to show you this, is that the length of AB, okay, the length of AB and the length of BC, whatever they may be, are going to be exactly the same, which we're going to say are equal. Now, another word that we're going to get more specific into is the term congruent. 2 line segments that are the same length, they are said to be congruent. And we're going to spend a little bit of time later in the course explaining the difference between equal and congruent. But all I want you to take away from today is congruent is a more specific definition of equal. So for right now, kind of think of them as the same thing. The symbol that we're actually going to use for this is we're going to use the equal sign, and we're going to have this little kind of squiggle, which is called a tilde for it. So I'm actually going to go ahead and readjust this and say that AB is congruent to BC. And that means that B actually has a kind of a special name for it. We're actually going to call it a midpoint, okay? So in that same drawing, I'm going to draw it down here, that B is actually going to be the midpoint of AC. And that drawing is going to be the same drawing that we have above here. So I'm not even going to make you draw it again. I'm just going to say the same drawing. Okay, that B is the midpoint of AC because B directly cuts AC into two equal parts. Or another way of putting it is it cuts the entire segment in half. And we're going to spend an entire day later in the week about something called the segment addition postulate, which we'll go into greater detail on. Okay? Again, feel free to pause at any point here. This is a good spot maybe to pause and go back and refresh some of these words that I've just gone over with you. But moving on, we have about 5 more here to go. The next one is called segment bisector. And so in this one, we're talking about any geometric shape that cuts another thing in half. And just like we said earlier, it's two equal parts. So an example of this that we can go with is we can say that line L bisects segment AC. So if I have that same segment AC, okay, that we've been drawing for the last couple problems here, here's AC. Line L is a line. I am simply going to use it to just cut it, just like that. And by cutting it, this point right here is technically going to be considered our midpoint, because that is the point at which cuts the A and C into two equal parts. And this line right here, I'm going to go ahead and label it, a little L right there, and indicate that line L is bisecting AC. Now, looking at definitions 18 and 20 in particular, we're going to need to look for a more specific way of communicating when two things are actually going to be equal. And so that leads me right into example 21, or definition 21. Marks that indicate two shapes are the same are equal. So what are we going to use to label that? Well, we are going to use the symbols to the right here. And I'm going to draw 2 examples here. Okay. So the first example is when two segments are exactly the same length. Okay. So I'm going to have segment G, E, and X, Z. When I want to say those two things are equal, let me switch to blue here for this. I'm going to use a little like dash mark, just to mark that those two things are going to be equal to each other. Okay. When we talk about angles, which we're going to get into later, okay, we'll sometimes use a little arc symbol with a little tally through it there as well. And so this angle, which we'll call ABC, D, E, F, those two angles are going to be equal. So going back to our previous examples, number 18, since we know AB and BC are congruent, one thing I might do is put a little dash on the AB and the BC to indicate to you that they're the same. Sometimes you'll see multiple dashes like this, and that's because in different shapes, sometimes there's more than one pair of congruent things. An example of that would be this parallelogram, okay? This side and this side are the same, but now for these two sides, we don't want to say they're the same as the first two. We want to say that they are a different length, but they are also equal. So you can use multiple lines to represent that this one and this one, those two are the same, and then you can indicate that these upper and lower ones are going to be a different length, but they're going to be equal to each other as well. Going back and just kind of finishing our example here at 20, since we know that line L was bisecting AC, we can now say that this midpoint is going to make this left segment equal and this right segment equal to one another. Okay. Now at this time, this will be a good spot to pause the video and try guided practice number 6. We're going to take a look at these questions. I am not going to go over them in this video, rather I will go over those in class. So either complete those right now, or you can wait till the end of the video and make sure you complete guided practice. We're going to wrap up the video with these final 3 definitions. Okay? And I'll provide some more visual on this in class, but I'm going to do my best to show this in video format to you. So parallel lines are going to be 2 lines with the same slope. You probably learned this from Algebra 1. Okay? And 2 lines that never intersect, that's also from Algebra 1. Now, the last piece here, 2 lines must be coplanar. I will talk a little bit more about this in person because it's easier for me to show you this and explain why this is true in person, but we're going to just kind of leave that there. I'm going to start to remind you of that. The symbol that we use for that, so let's say I draw 2 segments and I draw a segment AB and I draw another segment CD, okay? And if you notice, those 2 segments are parallel. If I extend them forever, they are never going to intersect one another. So one way that we can label this is this little like almost like arrowheads, okay? It doesn't mean that it's a line, it's actually indicating that they are parallel. So these are, I'm just going to make a little line here. This is the parallel symbol, okay? That's the parallel symbol. And the other way that we can describe this in writing is we would say AB is parallel to CD, and the symbol for parallel is two straight up and down lines, just like that. Staying on the same topic, looking at perpendicular. Two lines that intersect to form a right angle, and once again, I'll explain this second part in person because it's easier to visualize in a three-dimensional world than on the screen here, occurring on the same plane. Perpendicular basically means two segments that are going to meet at a 90-degree angle. So I'm going to draw segment GH right now. That's at the bottom. I'm going to draw segment EF. And those two segments are going to meet at a 90-degree angle. The symbol that we're going to use for that is we're going to say EF, we're going to say GH, and then in between them, we're going to put an upside down T. Upside down T is our perpendicular symbol. Okay? And just as a reminder, the square means 90 degrees. So just as a reminder, you probably already know that, but I wanted to just remind you. And for our final term, you might be familiar with parallel and perpendicular from previous courses, but skew lines is something new. And again, this will be something that I'll give you more depth of in class when we talk about this after the video. But skew lines are going to be lines that never intersect, however, they go in different directions. So the best example of this, I don't have anything for this first box, but I'm going to draw a picture of a box. Okay? And so just to kind of point out a few things here. So if I look at this box now, I'm going to switch to a red pen. If I draw this segment here and this segment here, those would be considered parallel. And the reason why they're considered parallel is the fact that they will never intersect each other, but they're also going in the same direction. All right, they're on the same side of the thing, of the box. These two right here are considered perpendicular because they're meeting each other and they're intersecting at exactly a 90-degree angle. Okay, but here's going to be that example of skew now. So what if I draw one right here? So this line that's going forward and backwards. I'm going to draw a different line that goes up and down. These two are never going to intersect each other, but they're going in completely different directions, which means they are on different planes. They are non-coplanar lines. And again, I'll show you this with some more visual examples in class, but this is going to be the general definition for skew line. And that is going to wrap up the video here on these final definitions of geometry. Once again, if you haven't done guided practice 6, please make sure you take a pause and do that. That's going to help you with the terms up to number 21, and then 22, 23, and 24. I want you to take a look here at guided practice number 7 and answer these questions as well. Once again, I won't go over those here in the video. I'd rather have you try those out in class, and I will take a look at those a little bit later with you. But that concludes this video. Please feel free to pause and rewind back any moment in the video to check things out. Thanks again for watching.